200 Panther tanks rumbled from their assembly areas before dawn on July 5, 1943. Their 44.8-ton hulls churning step dust as Panzer Brigade 10 advanced toward Prokhorovka's northern shoulder under clear skies. Within hours, 160 of them stood motionless across the grassland, silent, immobile, defeated not by Soviet shells but by their own engineering. The German Panther represented 18 months of frantic development since April 1942. When engineers studying captured T-34s at Kummersdorf drafted the VK 30.02 project in response to sloped armor that deflected rounds from Panzer IIIs and IVs throughout late 1941. Mann's design, selected over Daimler-Benz's competing prototype on May 15, 1942, featured an 80mm glacis plate angled at 55 degrees. Effective thickness 140 mm. Mounted to a hull that ballooned from the original 30-ton target to 44.8 tons by production start. The Maybach HL 230P30 engine, AET's 23.1-liter V12, generating 700 horsepower at 3,000 revolutions per minute, provided adequate power-to-weight ratio on paper, 15.55 horsepower per ton. Serial production of Ausfahrt D models began at MAN Nuremberg in January 1943. Chassis numbers 210001 to 210254 rolling off lines despite unresolved suspension issues flagged during September 1942 mild steel prototype testing. Shortages of specialized machine tools delayed hull machining even as assembly accelerated. Commanders desperate to field the new medium tank before summer offensive operations. The double torsion bar suspension with interleaved wheels, 660mm wide KGS 64/660/150 tracks providing 3.92 meters of ground contact, proved maintenance intensive, while final drives crumbled under combat weight far exceeding design parameters. On the steppe that July morning, Panthers halted as final drives seized. Maybach engines overheated in choking dust, and suspension components collapsed beneath loads they were never tested to bear. The 40 operational vehicles that reached engagement range demonstrated the KWK-42L/70's devastating capability. 75mm rounds launched at 935 meters per second achieved kills against T-34/76S at 1800 meters, penetrating 138mm of armor at 1000 meters. Range advantage the Soviet F-34 gun could not match. By day's end, Soviet anti-tank crews noted vulnerabilities their German counterparts already knew. 40 to 50mm side armor, 40mm rear plates, lower hull weak points exposed during maneuvering. The theoretically superior weapon had announced itself with mechanical suicide, burning through operational readiness before enemy action could determine battle outcome. If you're interested in how wars are actually decided by logistics, math, weapons, and doctrine, subscribe now, turn on notifications, and stay tuned for more in-depth World War II analysis. Let's continue. Late November 1941, somewhere in the frozen expanse west of Moscow, a German gunner peers through his sight at a Soviet tank 800 meters distant. He fires. The armor-piercing round strikes the T-34's hull and ricochets skyward, leaving only a bright scar on green paint. The Soviet machine angles toward him at 60 degrees, its sloped glacis deflecting death as easily as rain. German tank crews across the Eastern Front face the same nightmare. Their existing weapons cannot penetrate this geometry of survival. By April 1942, captured T-34s sit in German testing grounds, surrounded by engineers with measuring tools and notepads. They study every angle, every weld, every plate. The VK 30.02 project begins, a direct answer to Soviet innovation. Two firms compete. One design mimics the T-34's diesel engine and rear turret placement. The other adapts proven German engineering traditions to accommodate radical new specifications. weight targets climb from initial estimates to a final 44.8 tons, reflecting the reality that true protection demands mass. The predator that emerges carries technical superiority in every dimension. Its main gun, 5.2 meters of rifled barrel, launches projectiles at velocities the Soviet F-34 cannot match. Engagement ranges extend beyond 1,500 meters, distances where T-34 crews see only gray shapes through their crude optics, while German gunners align precision glass on vulnerable points. The Turmzielfernrohr 12 binocular sight transforms gunnery into surgical precision. Trained crews achieve 6 rounds per minute, each shell capable of punching through 138 millimeters of armor at 1,000 meters, more than sufficient to defeat any Soviet medium tank from distances that guarantee first shot advantage. The Cat's frontal protection establishes new defensive standards. Glacis plates angled to deflect rather than absorb, creating effective thickness that transforms nominal measurements into survival margins. Side armor tells a different story. Vertical plates measuring only millimeters thick, vulnerable to flanking attacks and close quarters combat. Soviet intelligence officers circulate this information through Red Army tank battalions within weeks of the first encounters. By mid-1943, Soviet tankers carry explicit instructions. Avoid frontal engagement at all costs, maneuver for side shots, use terrain to close distance before the German gun finds its mark. The technical specifications that make Germany's sloped armor counterstroke deadly at range become liabilities in close combat, where maneuverability and numbers overwhelm sophistication. The Maybach engine requires 30 minutes of warm-up in temperatures below -20 Celsius, a tactical weakness in Russian winters. The camera now positions itself inside a Soviet tank commander's cupola, studying reconnaissance photographs of the Predator's weak points, preparing protocols for survival against superior firepower. Between 1943 and 1945, German factories delivered approximately 6,000 Panthers to the front lines. Soviet industry produced roughly 57,000 T-34s during the same period. A production ratio of 9 Soviet tanks for every Panther rolling off the assembly line at MN, Daimler-Benz, and MNH Hanover. The mathematics of industrial warfare rendered tactical excellence strategically meaningless. Each Panther demanded 150,000 man-hours of skilled labor, precision machining required for its 80mm glacis plate angled at 55 degrees. The Maybach HL-230P30 engine's V12 complexity and the 75mm KWK 42 guns exacting tolerances. A T-34/85 required 3,000 man-hours, 50 times less investment for a vehicle that could penetrate Panther frontal armor under 500 meters with its 85mm ZIS SS-53 gun. The resource calculus grew more damning with examination. Material and labor allocated to Panther production could have manufactured 15,000 to 18,000 Stug 3 assault guns, vehicles weighing 24 tons instead, of 45.5 tons, consuming half the fuel per kilometer, mounting adequate 75mm guns for defensive operations. By mid-1944, monthly Panther output peaked at 330 units across 3 factories, while Soviet assembly lines at Kharkov, Nizhny Tagil, and Omsk maintained relentless 50 km/h production velocity, matching the T-34's cross-country speed. Operation Bagration on June 23, 1944, exposed the arithmetic's consequences. Army Group Center fielded approximately 118 Panthers against 2,715 Soviet tanks, a 23-to-1 numerical disadvantage that no amount of superior optics or sloped armor could overcome. Ammunition shortages reduced German allocations to 40 to 60% of requirements, while retreating units abandoned Panthers when fuel lines ran empty. The operational range of 200 kilometers on roads reduced to 100 kilometers cross-country at fuel consumption rates of 700 liters per 100 kilometers created logistical chains German infrastructure could not sustain. Oberfeldwebel Ernst Barkman's Ambush near Lorey on August 8, 1944, demonstrated the paradox perfectly. His Panther Akosfixid G destroyed 9 M4 Shermans in 30 minutes from a static roadside position, a tactical masterpiece. The damaged vehicle required 3 weeks of mechanical repairs to final drives and transmission before returning to service. 3 weeks during which 9 T-34s could have been manufactured from raw steel to frontline deployment. British armor reports from Normandy operations acknowledged Panther superiority, recommending flank attacks and close-range engagements rather than frontal confrontation. The recommendations arrived as admissions that quality without quantity secured nothing but footnotes in industrial war's ledger. The road junction materializes through vision slits 200 meters distant. Barkman's Commander Cupola offers 7 periscope views of the Norman hedgerow maze southwest of Lorey, morning sunlight filtering through oak branches onto the concealed steel CAD, positioned hull down behind the roadside embankment. Engine idling at minimum revolutions preserves fuel in a theater where consumption off-road demands 700 liters per 100 kilometers. The crew has maintained radio silence since dawn positioning. Grinding diesel notes announce the American column before visual contact, a procession of M4 medium tanks advancing without reconnaissance screen. Turrets traversed forward in transit configuration rather than combat spread. First shot at 08:47 hours. The 75mm KWK-42 reports with a crack that reverberates through the 45-ton hull. Long barrel recoil driving hydraulic buffers rearward as the gunner acquires the second target through his Turmziel Fernrohr optic. Penetration at this range, under 300 meters against vertical Sherman plate, requires no calculation. The loader slams the next round home. Brass clatters against bulkhead plating. Cordite stench fills the fighting compartment as the ventilation system struggles against accumulating propellant gases. Methodical gunnery doctrine learned across 4 months of crew training transforms chaos into sequence. Identify, range, fire, observe, traverse, reload. 9 vehicles destroyed before 0917 hours, their burning hulls transforming the intersection into a crematorium of welded steel and stored ammunition. Textbook ambush execution. Barkman's crew demonstrates what elite personnel extract from this weapon system when positioning, concealment, and first shot advantage align. The AUSFG variant carries redesigned ventilation inherited from May 1944 production conferences. Side armor protected by 5mm shirts and skirts. Chassis numbered from the 120301 series that marked the type's 3rd major iteration. Every mechanical advantage counts when operational range on roads barely reaches 200 kilometers before refueling. Withdrawal reveals the cost. Final drive assemblies show stress fractures from combat maneuvering. Transmission requires complete servicing after the engagement's mechanical violence. 21 days of repair work follow 30 minutes of tactical perfection. A maintenance to combat ratio that explains why peak performance remains statistical outlier rather than operational norm. The ambush vehicle sits immobilized in a field workshop, while American columns continue flowing through Norman crossroads. The Wehrmacht's most capable tank destroyer, sidelined by the same precision engineering that enabled its lethality, waiting for replacement parts manufactured in factories already targeted by strategic bombing campaigns. The Panthers' combat debut at Kursk in July 1943 revealed a machine designed for perfection but built for collapse. Transmission failures crippled formations before contact. Final drives seizing after minimal road marches. The ZFAK 7-200 gearbox, a Synchronsch manual with 7 forward speeds and a 4 km/h reverse, required complete front hull disassembly for field. Repairs: 150,000 man-hours per unit with specialized tools that rarely reach the front. At Korsun-Cherkasy in January 1944, dug-in Panthers exploited their KWK-42 guns and 100 to 110mm turret armor in defensive positions, inflicting disproportionate losses on Soviet armor. the Wehrmacht finally understood how to employ the weapon: static, hold down, compensating for mechanical fragility with positional advantage. Soviet crews developed specific recognition protocols for the Panther's silhouette, targeting the 40mm side armor with flanking maneuvers and coordinated artillery calls. By late 1944, crew training had collapsed from 3 to 4 months at facilities like Winsdorf to 6 abbreviated weeks. Allied bombing devastated production plants, alloy shortages strangled transmission manufacturing, and spare parts for final drives became non-existent across MAN, Daimler-Benz, and M&H factories. American evaluations at Aberdeen Proving Ground documented 50 to 60% operational availability compared to the Sherman's 70%. The French Army captured enough Panthers to operate them in training exercises through the late 1940s, acknowledging the gun and glasses as exceptional while noting complexity as fatal flaw. Field modifications like 5mm Schürzenskirts on Ausführung G variants attempted to address tactical vulnerabilities, but production had already peaked. April 1945 in Berlin rendered all previous calculations academic. Panthers sat emplaced as static pillboxes in urban rubble, fuel tanks empty, mobile ammunition exhausted. The KWK-42 remained functional, but the 8.86-meter hull had become a fixed fortification. Total production reached approximately 6,000 units across AUSFD, 842 units, A, 2,200 units, and G variants, plus 339 Berge Panther recovery vehicles. A theoretical 10-to-1 kill ratio multiplied across 6,000 Panthers yielded 60,000 enemy losses, a figure Soviet factories replaced in months, not years. The war's outcome had been decided by production, capacity, and resource mathematics, not by the Brunel hardness rating of 265 to 309 on a 60mm lower glacis plate angled at 55 degrees. Soviet engineers examined captured Panthers at Aberdeen and Soviet facilities, measuring what German industry could build but never sustain. On that step at Prokhorovka, the answer had already been written. 200 Panthers reduced to 40 operational machines before the battle truly began. Engineering excellence defeated by its own complexity. If you enjoyed this story, hit subscribe for more.